So there's a lot to take in when you first look at a problem like this. And what I always remind people of is, just take an extra breath. Sometimes when you first look at a problem, it can be a little bit overwhelming. And if you just take that extra breath, it'll give you a chance to sort of get your mind ready to attack what you're looking at. So first things first, when I see a graph, I always want to know what that graph is. So what we're looking at right now is the graph of the function of f. So this graph up here is our f of x graph. Then we're talking, they give us some horizontal tangent lines at 1 and 4.5. So then that's telling me that there's a horizontal and there's a horizontal. And then they tell us that g is the function defined by this equation here. So when I see that going on, kind of one of the first thoughts I have is I'm looking at the fundamental theorem of calculus. Which, when you see that x, when you see a variable up in the top right there, that's kind of got to be one of the first things that pops into your head. Then they're asking us, for what x values does the graph of g have an inflection point, a point of inflection? Well, that means if I'm going to find out if something has a point of inflection, I immediately have to know, first and foremost, where does that second derivative equal 0, or where is it undefined? Right? That's the first thing that I need. The second thing I also have a point of inflection is that this needs to change concavity. So your graph needs to change concavity. Since we're talking about g here, we really want to know, when does g's second derivative equal 0, or when is that undefined? So now you say to yourself, well, I've got an equation with g and I've got f up above. So I'm hoping something's going to come together here. We look at g of x and you say to yourself, all right, well, right now I know that I need to get to the derivative. I need to get further than the derivative. I need to get to the second derivative of g. Well, we take the equation they give us and all we can do is take the derivative of it. So we're going to ddx both sides of this. The derivative of the left, that's now going to be g prime of x. This piece on the right, this is our fundamental theorem of calculus. Whenever we go from a number on the bottom up to an equation, up to something with x, you're undoing that antiderivative, right? A derivative is canceling out the antiderivative, and what you're left with is that x plugged in there now. So this antiderivative becomes f of x. And again, that's the fundamental theorem of calculus part 1 right there. And it's always with that x up at top that really you just got to recognize this and know what to do with it. So from there, I can see that g prime, the derivative of g, is equal to f of x, which is my graph that I'm looking at over here. So now what I also know is that this is the graph of g prime of x. That gets me to a point that I need to be, but not all the way, because I'm still trying to find the second derivative. So I take my derivative again. The second derivative of g is equal to f prime of x. So that's equal to the derivative of the graph. So what that tells me is if I'm going to read off my second derivative information, I have to read the derivative of this graph. So to read the derivative, that's always where off a graph, you always want to use what I call the derivative triangle. Wherever the graph is headed up and increasing, that's a positive derivative. Wherever the graph is headed down and decreasing, that's going to be a negative derivative. And wherever that graph goes horizontal for a second, that's going to be a 0 derivative. And so we're going to use that information to read our second derivative from the first derivative off of f. So reading our derivative now, I start over here on the left, and what I'm seeing is this section is increasing. So this would be plus, 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 plus. Then they told me I had a horizontal tangent line here, so that means my derivative is 0 there at 1. And then the rest of this is going negative. So decreasing, 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 negative, negative. I get back to the other place they told me I had a horizontal tangent line. That's another 0 right there. And then off of there, I'm going plus, 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 plus. So what we just read off of that graph, that's the derivative of f prime. But when we read it off of our first derivative, it's giving us second derivative information. So what we have in front of us is second derivative information. And the easiest way, when you're first learning this especially, is to kind of take that now and put that info onto a number line. So I'm going to put a second derivative number line. I've got g prime of x, my second derivative is equal to 0 here at 1. That's a possible inflection point right there. I've also got my second derivative is equal to 0 at 4.5. And now I just need to see, I've taken care of this part now. They both are the points where my second derivative is 0. And then I just read off if it's changing concavity. Well, to the left of my inflection point, it's positive at 1. To the right of my inflection point, it's all negative, so in between my two possible inflection points. And then after 4.5, my other inflection point, I'm now back to a positive. So I'm going concave up into concave down, and then I'm going back to concave up. And so what I can see is that at both of those points, at 1 and 4.5, I'm also fulfilling the second criterion, that they change concavity at that point. So what I know is my only two inflection points are happening at 1 and 4.5. So here you've got to keep track. The big deal on this is remembering how to keep track of what level you're at for what you care about. So it's an f of x graph, but it's telling us g prime and g double prime of x information. So a little bit tricky here, but definitely doable. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.